So we start with the Consolidated Drained Triaxial Test. The first one is the Consolidated Drained Triaxial Test, also known as CD. Okay, so you need to understand each type of triaxial test. You have to understand the concept. Okay, the first step, kita go step by step. The first step is the sample preparations. Okay, for the sample preparation, as I mentioned earlier in the introductions, that there are three types, the common types of the triaxial test. We have 38 mm diameter, we have 50 mm diameter, and 100 mm diameter. But the requirement for the specimen in a cylinder shape, it should have this ratio, 1 diameter to 2 length. Okay, so 1 size of the diameter to 2 size of the length. For example, we have 38 mm diameter, so we should have the length of the sample 76 mm. So we can have 50 and 100, and also 100 and 200. But the commonly used of the sample size is 38 mm with 76 mm length of sample. Okay, then after that we have prepared sample. We go to the second stage, is the saturation stage. Saturation, the word of saturation kita dah jumpa since chapter 1. To moist the sample, nak tahu moisture untuk nak basahkan sample. So we need to saturate the sample, to wet the sample until the sample fully saturated. Okay, so how it goes. So we need to fill up the cell cylinder first. The cell cylinder is the balang kaca yang I mentioned earlier, the glass cell cylinder, with the water till full of the cell cylinder. And then in order to wet the sample, so we need to allow water to flow into the specimen through the back pressure line. Okay, daripada back pressure line, so kita allow water to infiltrate into the soil sample, soil specimen. Okay, and then how to indicate that sample to dah fully saturated. So we need to wait till the sample to be fully saturated with the B value. B is the Scampton pore pressure parameter. So if the B value reading, yang kita monitor through data logger dan juga screen komputer tu, if it shows that B equal or more than 0.95, so that we already reach the fully saturation stage, maknanya dah 95% or more. Okay, so and also the graph of that process akan tunjuk constant, maknanya the graph tu akan bagi nilai constant. Kalau ini U, so dia akan tunjuk nilai constant. So when it's constant, bila dah constant, maknanya we dah achieve the fully saturation stage. Okay, so bila kita dah achieve the saturation stage, we can proceed to the next stage, is the consolidation stage. Since kita conduct tadi adalah CD test, consolidation drain test, so this consolidation stage refer pada C tu. So what is consolidation? Consolidate ni is actually to kukuhkan, to stable the sample, to strengthen the sample by the compression. So in order to ensure that this process occur, so ada dua condition. Yang first kali, we will apply the sigma 3. Okay, sigma 3 cell pressure. We apply it isotropically. Okay, apa maksud isotropically? All around the sample will receive the sigma 3 yang sama. For example, if we apply sigma 3 equal to 50 kPa, so each round of the sample will receive 50 kPa. So the cell pressure akan go through the cell pressure transducer. And also, to ensure that the consolidations happen, we need to open the valve here. At the pore pressure line, there is a valve. So we need to open the valve. When we open the valve, the water will flowing out. So kita dah apply pressure, so that pressure tu akan menolak air untuk keluar. So once the water flowing out, so the sample will slowly strengthen their body of soil. Okay, alright. So we need to monitor the movement of the pore water pressure, because before we proceed to the shearing stage, we must achieve the constant consolidations stage, and then the indicator is based on the pore water pressure. So let's say we have U over the time here. So initially at the beginning of consolidation, U ni dekat atas. Okay, why? Because before consolidation, tanah tu kita saturate. So bila saturate, dia ada amount of water kat dalam tu. It's not zero, dia ada some amount of water, sebab tanah dah totally moist. So it's somewhere here. Okay, when we start the consolidation, kita apply sigma 3, and at the same time kita open the valve. So air will reduce, U will reduce slowly. Okay, till the end. It can be 0, maknanya at the end of consolidation dia equal to 0, or if it's not 0, the value dia akan reduce to small value, let's say 1 kPa, 2 kPa, and then it will constant. Indicator dia, if it's not 0, it will constant. So, and there is no water flowing out. With the sigma 3 tadi yang kita apply, at certain time dah air tak ada nak keluar dah. Kita dah constant. Okay, ataupun dia ada satu nilai U yang mana dia tak bergerak lagi, which is constant. Okay, so when it achieves that condition, it shows that the sample already fully consolidated. So during the consolidation process, at the same time volume will reduce. Why? Because water coming out. Okay, so dia mengurangkan volume dalam specimen. Okay, when we achieve the consolidation, fully consolidations, we will proceed with the next stage. The next stage, or the last stage actually, is the shearing stage. In the shearing stage, we need to investigate the failure behavior. Okay, so how? So we will apply the sigma D, or also known as deviator stress. Okay, so previously the sample already received sigma 3. Okay, and then during the shearing stage, we add with the deviator stress sigma D. So axially, at axial stress, which is sigma 1, is actually equal to sigma 3 plus sigma D. So we have the sigma 1. So kena tahu this yang penting ni, sigma 1, sigma 3, sigma D, because nanti dalam analisis data ini yang kita akan gunakan. Okay, again, since this is the CD test, kita conduct CD test. Consolidation dah clear. So now the second term is referred to the shearing stage. So during the shearing stage, kita tengok dia punya valve condition. Kalau drain, D maksudnya drain. So drain out, air will flowing out. Okay, so in order to allow water to keep flowing out, we need to keep open the valve. Okay, sama dekat pore pressure line tadi, the valve tu we need to keep open. Teruskan dia buka, jangan tutup dia, because we want to drain out the water. Okay, so the sample, the water within the sample will drain out. Okay, so this process, kalau kita monitor the progress of U, let's say kalau U equal to 0. Kalau U equal to 0 at the end of the consolidation stage, so dalam shearing stage it will continue lah. Even though kita tambah sigma D, tambah lagi beban. Okay, so it will keep constant equal to 0. Sebab tak ada air lagi nak keluar dah. There is no generations of excess pore water pressure. Okay, let's say if there is some amount of water yang masih ada lagi tinggal sikit-sikit dalam sample. Okay, during the shearing stage, bila you apply load, so kita akan tengok air will decrease, will end sampai ke 0 juga at the end. Okay, sampailah pada sample fail. Okay, so we will keep increasing the sigma D. Maknanya bukanlah satu sigma D sample akan terus fail. So let's say kalau sigma D yang pertama 50, sample tak fail, so we increase the sigma D. Sigma D yang kedua, let's say 100, sample still not fail, so keep increase the sigma D, and then 150, and at 150 it failed, so we stop at sigma D 3, which is 150 at failure. Okay, so sigma D will keep increase until the sample fail. Alright, okay, so this is the 3 types of the shear failure in the triaxial test. Okay, we have the brittle shear failure, partial shear failure, and also the plastic yielding failure. Okay, alright. So this is the typical form of the CD test failure envelope. At the end, daripada data CD test tadi, kita akan plot the graph, and the typical plot for the CD test failure envelope ni adalah like this lah. If you can see that we have sigma prime and angle of friction prime. So why it is prime? So bear in mind that when we are conducting the CD test at the end of the day, U will equal to 0. Remember, we have learned about the total stress and effective stress. Effective stress will equal to total stress minus U. So if we have total stress minus U equal to 0, so you will have the value yang sama for the effective stress. Alright, so the CD test actually will give you the effective stress, shear stress analysis. Okay, so CD test give you the effective shear stress analysis. You will have the sigma prime, so you will have the shear strength parameter is C prime, and also you will have the angle of friction prime. Okay, for the CD triaxial test.